process that I explained through the import option, you can also import, right? So another way is you can see that whenever we clicked on the import menu and we just imported our CSV file, you can see that in the console panel something is written, right? So what is this? This is the code to import. This is the code to import a CSV file into your R Studio. So what is the function written here? So the function is written that read.csv. This is the function. And what is this? This is within double quote. You have to write the location. That means where your CSV file is located. So this is the location. This is the name of your file, that is book one. And .csv is what? This is the extension, right? So if you do not want to import directly by clicking on this import shortcut menu, you can also write this code and everything. This code I want to store that in a variable that is book one. So now book one consists of the entire data set that I have created. Okay. Then if you want to just see what are the data present in my file, you have to view that. Okay. So let see that whether my code is this code is running or not. Just copy this, paste in the code editor. Okay, click control enter, right? Then here you have to again copy this, then paste here, then click here control and enter. You can see that I am getting the same output. So here there are two ways by which you can import the CSV file that is created by you. Either you can import from here, from this option, or you can directly write the code to import the file that you have created. Okay, so there are two ways of importing the CSV file. Okay, everyone is clear up to this. Do the same coding and see that whether everything is coming okay or not. Okay, right. Then this was all about your CSV file. You can also create an Excel file. Okay, so you can also create an Excel file. You can also insert data sets, data values in that Excel file. That means you want to create an Excel file of your own. This is one of the data set also. Then if suppose you have created an Excel file, okay, just open the Excel and you can also insert the data simple way. Okay, so you have created the Excel file and there you have inserted your data, the data you have collected and you have inserted that. So I want to work with the Excel file that is created by me. Okay, you want to work with the Excel file that is created by you. So how we can do? There are also two ways. So first one is just click on this import. Okay, from Excel, from which file you want to import, that is the Excel file. So I want to get data from the Excel file, so I have to click on from Excel. So whenever you will click on from Excel, that you have, okay, you have to give the name of the file. You can see here code preview is given here. You want to install read Excel, right? So I have already installed read Excel. So whenever you first time click on importing the Excel data, it will ask you that read Excel file is read Excel package is not yet installed. Do you want to install read Excel? Yes, so you have to click on yes. And as we know that how the packages are being installed, whenever you click on yes, this read Excel package will already be installed. Okay, so after that you will get this kind of interface, right? So I have already installed read Excel, so it is not asking me again to install this read Excel. So it is directly calling the read Excel. So library within bracket read Excel means read Excel package is already installed to access the data from the Excel file, and it is calling now. This library function is now calling this read Excel file. That means now the read Excel will be in use for us. Okay. So this is the coding. If I want to read the data from the Excel file, the function is read underscore Excel. Why it is null here? Because I have not browsed any file. So whenever I will browse my file and the file name will be written here, so this null will be replaced with that file along with the location of the file. So after getting that, everything, this right hand side is now stored in the left hand side variable, that is data set. That means this data set now consists of the all the data present in my Excel file that I want to import. So if I want to see the Excel file along with the data present in the Excel file, so I have to write view function with V as capital letter and the data set. Okay. So whenever I write this entire Excel file and the data present in the Excel file will be displayed for us. So what will I do now? I have to browse to get the Excel file. So let I have stored my Excel file in the desktop and the name of the Excel file is, this is practice R. Okay, practice R is the name of my Excel file. I will just click on open. So whenever I will click on open, you can see that data preview is here and it is showing that in my Excel file, that is practice R, it has table ABC data values. And you can see that previously here within read underscore Excel function, it was written null because I have not browsed any Excel file. So as I just got the Excel file, so now within read underscore Excel function, it is considering the location, okay, the location of the file along with the name of the file. So this is the location. My file is present in C drive, users Asus desktop, and this is the name of the file, practice R, and .xlsx is the extension of the Excel file. Okay. So everything is now stored in this practice R data set. So whenever I want to view the Excel file, so the data present in the Excel file, so I have to write view function and within bracket the variable. Okay. Here you can see the name of the Excel file is practice R. Seeds are by default. Range is given. Maximum rows also you can write. Otherwise, skip that. It doesn't contain any NA value. So that's why this box is blank. And here two tick marks are there. That means first row as names. That means we know that these are the first rows and these are written as names. That means names of the file, the columns, right? And this here, I want to open that in data viewer. So that's why whenever I just clicked on the browse option, the everything present in my practice R file is now shown here in the data preview. So that's why it is in tick mark option. Okay. So up to this clear, you have to import. Okay. So tell me everyone, up to this, am I clear? Everyone, do the same process. As I have installed the file read Excel, so it is directly calling the read Excel file. That is library function is used to call the read Excel file. So whenever you will first time click on importing from Excel file, it will ask you. There will be a prompt bar that will a warning message will show you that do you want to install this read Excel package? Yes or no. So you have to click on yes. It will take time. It will take few time to install this read Excel. Then after that you can get that pop-up interface to browse the file and you can import that also. The process that I showed, it will be the same process. So everyone just do the same and tell me that you are getting the same output. Okay. Is there up to this any doubt? Are you all okay with the coding, with the explanation? Okay. So did you all install the imported the Excel file? Okay. Did you all import the Excel file through this import shortcut menu? The process that I told you that you have to that we do not have to install read Excel, that will be automatically installed if you permit that. You can see that in the right hand side in the third panel it is written that practice R. This is the name of my Excel file. It has three variables like A, B, C and two observations. So two rows are there. So 5, 10, 15, 3, 13 and 23. So this is one of the method by which we can import the Excel file. Okay. So there is another method also by which you can also import the Excel file by writing the code. Okay, how we can do that? You know, here whenever we just imported the Excel file in the console panel, you can see this is the code. Read underscore Excel is a function by which or which is used to import the Excel file. That means within the bracket you have to give the location. So this is C drive users Asus desktop. This is the location of the Excel file that I have created, right? So this is the name of the Excel file and this is the extension of the Excel file. So if without clicking on the import shortcut menu you want to install the Excel file, you can use this coding directly. Okay, control this, just copy this here, then paste here, then press control enter. You can also uh, view, you have to view that, then copy this, then paste here also and control enter. Okay, so whenever you will just click on control enter, you can see that A, B, C, three variables are there, two columns are, two rows are there, so two observations are there and three variables are there. This is the double values, right? In R it is called double value, double data type, right? So this is the way by which you can also import your own data set. So in this session we just learned that how we can deal with the, you can say that CSV file, and how we can work with the this Excel file. There are two ways by using which you can also import the CSV file, you can also import the Excel file. First way is by going to the third panel. You have to click on the import menu, and there you have to click on the Excel, or you have to click on the CSV value import function. Okay, so after clicking on that, you will redirected to the place where you have stored the CSV file or the Excel file. So according to the thing that you want, that means according to the file you want, whether you want the CSV file or whether you want the Excel file, so you will just click on those and click on import, right? So whenever, one thing you remember, that whenever you want to import the Excel file at the first time, then it will ask you to that whether you want to install the package that is read Excel. Okay, so read Excel is the package which support read underscore Excel function. So this read underscore Excel function here, you can see this read underscore Excel function is supported by the read Excel package. So if we want to read the data from the Excel file, you have to install the read Excel package. So it will ask you that whether you want to install or not. So we need to install so that we can use the read underscore Excel function. So we'll just click on yes, we want to install. Then it will take few time to install the read Excel package. After that, you will just get that interface that I told you, that it will show you to browse the file. And whenever you browse the Excel file, that the in the preview, the code will be written, and in the data preview, the data, that means the file you have created in the Excel extension, that will be displayed. Okay, so this is the way, two ways, right? So up to this, any doubt? Any doubt? Any of you want to ask me anything about this import of CSV and Excel file, two ways that I just demonstrated you? Okay, so are you all executing the same? Okay, no issue. I think I am very clear to everyone. Okay, Anas. So whenever you do practice, just follow the steps that I told, and you will get that how your Excel file, Excel data set, and how the CSV file data set can be important, and you can do the same operation, right? So we have just, as you know, that we just performed the correlation operation here. Let me show you that. What you have we have just completed, we have completed the correlation portion. That means how we can find out the how the values are correlated with each other. So you can see that, let me the screen is visible. So we have just completed this R Studio and R programming language, the basic analysis, and we have also performed this working with the sample data sets. So we have just continued with Irish data set, we continued this empty cars, we continued with CO2 data set, we also continue with the air quality data set. That means different sample data sets that we considered and we also worked. Okay. So we also did the data analysis, how we can find the structure of the file, sample data set, how we can do various operation, how we can find out the mean, maximum, minimum value, how we can find out the standard deviation, everything we have completed. We have shown the visualization also. That means how to draw the line graph, how to draw the bar chart, how we just that means we just imported or we just installed the ggplot2, etc. So histogram, in the form of histogram also we plotted the data. We also find out how the values or the variables are correlated with each other, positive, negative, zero correlation, everything we just completed. We also find out the Pearson correlation, if you remember that Pearson's correlation in R. K means clustering analysis, we have also completed. Okay, so we have continued three classes over that K means cluster analysis to continue to complete this portion. Okay, so now we will study that hypothesis testing using R. Okay, so these are the topics of practical that is generally present in the data science lab, right? So as we are dealing with cloud and data science lab, so we have to do all these things. So up to this we have completed, and also we just studied one more additional, that means how we can deal with the na values in the RStudio interface. Okay, so if you are using RStudio, we are using the sample data sets how we can remove and how we can find operations on the data set, sample data set. And today also I told you how we can import our own data set. So if we have created data set, how we can import that, how we can use that. We can also perform same, the all data analysis, visualization, correlation, Pearson correlation, K-means clustering also. The process will be same, everything will be same, but the data set will be our own data set that we imported. Okay, so everybody try to do the same operations. Visualization of your data that you have created, find the correlation analysis. The process that I told you, everything will be same, but the data set will be changed. So at that time, we are dealing with the sample data set, but whenever you will perform, try to do with the own data set that you have created. So up to this, up to fifth number, all of you try to perform the all of the operations on the data set that you have created by your own. That means you have imported by your own. The process by which we can import the data set, I also told you how we can import by using directly the import option or by using the code. Okay, so now we will study the hypothesis testing using R. That means if we are dealing with the data set, how we can test the null hypothesis, how we can test the alternate hypothesis, how we can find the t test. Okay, so as you remember that in case of hypothesis testing, we can consider the t test, we can also consider the z test. So today we'll see that how the t test, that means hypothesis testing, can be performed on our data set, right? Okay. Listen this very carefully. This is very useful that how we can perform the t-test, how we can perform the hypothesis testing on the sample data set that we have taken, right? So just open your R Studio there. You can see before just explaining the code, let me introduce with the hypothesis testing, a brief recap, right? So let's start from here. Up to this we have completed. Then this is, yes, this is. See, in case of hypothesis testing, what we have to do? Hypothesis testing means we have to test the hypothesis that is generated by us. That means we have collected the data and we are thinking that this is the way by which we can go to our conclusion. We can find our conclusion, or we can conclude our problem, or we can conclude our analysis. So the hypothesis that we have taken, or the assumption we have generated, we have to test the hypothesis that whether the hypothesis that we have generated is true or false. So that is called hypothesis testing. So hypothesis testing, we know that we always deal with the sample data set because we do not apply on the entire population. So from the population, from the large data set, we collect, we extract the sample data set, and upon that we just perform the operation, right? So hypothesis testing will also be performed on the sample, right? So hypothesis testing are how many types? Generally, we study the t test and z test. So today in this lecture, I will say that how we can perform t test on the data set to test the hypothesis, right? The null hypothesis, the alternate hypothesis that we have generated, how we can test that whether the null hypothesis will be accepted or whether the hypothesis will be accepted. Okay, so t-test is, because as we are touching upon the t-test in today's lecture, so we will just find out what is the t-test. So t-test is nothing but it is a very simple t-test, right? So one sample t-test means it is a very simple funda is there. So entire population is there, right? Entire population. We want to extract the sample to do the analysis. So in the sample, we can also get the mean, and from the population, we can also get the mean. So we have two means mean. That means MEAN. This is the mean. So mean of the sample and mean of the population. So in one sample test, we want to find that whether there is any significant difference between the sample mean and the population mean. So that will be tested in the sample T test. So up to this, am I clear? Like test. This is one sample test. Perform the t-test. So in order to perform t-test, the data should be normally distributed. Okay, you know very well that what is the meaning of normally distributed data. That and should be considered, and the sample shouldn't be more. That should be the it shouldn't be minimum, or it shouldn't be maximum one. It should be smaller than that. So in one sample test, perform the population we want to find, we have to find the sample mean, we have to find the population mean, and we will check in the one sample t test, we'll check that whether there is any significant difference between the sample mean and the population mean. So entire our one sample t test, it is based upon to check the difference or the similarity upon the sample mean and the population mean. So this is called one sample t test. Okay. Then another type of test is called independent sample t test. Right. So let me introduce one thing in this one sample t test, that null. You know that how many types of hypotheses there are? Two types. That is null hypothesis and alternate hypothesis. So why I'm explaining all these things, because we will have to find out all the operations, all the analysis in the R studio. So in R studio, we'll just open, we'll take the data set, I will perform this one sample t test, this independent sample t test, dependent sample t test. At that point, we'll also consider the null hypothesis, we'll also consider the alternate hypothesis also. Okay. So if we are considering this one sample t test, that means we are now to find out the that means the difference or the similarity of the sample mean and the population mean. So if we will consider the null hypothesis, this says that there is no significant difference between the sample mean and the population mean, right? Because null hypothesis say there is equal symbol. Okay, you know that very well, that a null hypothesis say that there is no difference. That means both are equal. But alternate hypothesis say no, there is difference. That means the first one can be greater, or the first one can be smaller, or there is some variance between the first and the second one, right? So if we'll consider in case of one sample t test the null hypothesis, it will say that there is no significant difference between the sample mean and the population mean. That means the sample mean is equal to the population mean as per the null hypothesis. Okay. So let's consider this independent sample test. So here in the independent sample test, it is carried out when both the groups are different. Okay. So there are two groups. Here there are two groups. This is one group. This is another group. That means these are, let this is process A, let this is process B. So two samples are generated from the population, and these two samples, these two groups are different. So if yeah, between the different sample groups, we have to perform the analysis that whether there is any significant difference between the sample of between the mean of these two sample two different groups, or there is any difference. Okay, there is no difference between the mean of these two different sample groups. So in that case, we have to perform the independent sample t test. Okay. And in this case, the null hypothesis say that as we know, this is one group, this is one another group, this is one sample, this is another sample group. So null hypothesis say that there is no significant difference between mean of these two groups. We have to find the mean of this, we have to find the mean of this sample, and the null hypothesis will say that there is no significant difference between means of these two groups. So this will be the null hypothesis in case of independent sample t test. Okay. So one more type of t test is dependent sample t test. So in case of dependent sample t test, this will be the population. This is the sample extracted from the population. So we have to consider only one sample, but the same group or the same sample group is tested before and after the treatment. That means suppose few treatment will be given to this sample that we have collected from the population. So before giving treatment, the mean of this sample is compared, which taken, and after giving the treatment, the mean of this sample is taken. Okay, so we have to compare the mean of the same group before giving treatment and after giving treatment. That means before doing any analysis, before applying on any experiment, we have to find the mean of this sample group, and after giving the treatment or after performing the experiment, we have to find the mean of this sample group. And as we receive these two means, we have to compare that whether there is any significant difference between the mean of the same group before and after the treatment. Okay, so here also a null hypothesis say that there is no significant difference between means of this same sample before and after the treatment, right? So these are the three types of t test that is generally performed for the hypothesis testing, and we will just implement these three types of t test on our data set in R studio to see the execution or to see the output. Okay, so up to this, any doubt? Just look at the slide, and you can ask me also if you do not understand at any point. Three types of t test we'll study in today's session. That how, if we have a data set, if you have a sample data set, or if you have a data set that is created by us, then how we can perform this t test. That means how we can perform these three types of t test on the data set to get the output. Just read the slide and ask me if you are getting any doubt at any point. Okay, everyone, just read, try to understand. See, we have just completed this fifth and the sixth experiment that is related with the NA values in the data set, and the seventh one that is continuing that how to import the data set that is created by us. And today also we are just reading how we can so we have done with the 8 experiments. I hope all of you are practicing the same at your home. That after my session, all of you are doing the same execution, so that you will be clear about what is going on in the lab classes. So anything you want to ask about hypothesis testing? That the three types of t test that we want to perform in the R studio. Any student, any having any doubt? If you are facing any doubt, please ask me. Okay. Okay. I hope everyone is clear. Then just we'll see that we will take a sample data set and we'll check the hypothesis testing is working properly with the data set or not. You can also work on a sample data set or the way which you can also import your own data set. You have properly created your own data set. You can also import that data set that I told how to import. Okay, you can also import the data set and you can also work with your own data set. So it's your choice that how you want to do the execution, right? So I want to take the sample data set to do the hypothesis testing. For hypothesis testing, I will just work upon the t test in today's session and I will just demonstrate the three types of t testing and the values, what are the values we can receive. Or this will show you that if you have a data set, you have collected data upon something, you want to do an experiment. So for that, you have created a CO2 file is now attached with the R Studio. So up to this, getting the same output. Are you getting output? Every okay. Don't find this first I I have the entire data sample I the and population may different or if this is my sample you can do here t test because the to only day test okay t for that I have to write function that is t dot test t test then I want to perform t test on which one on which variable so let I want to perform t test on this optic okay you can also perform on any others but I want to perform the t test on the optic okay so you have to perform on concentration also on optic also so these are the values in numerical values so you have to perform t test upon that okay so let I'm considering this optic of CO2 or the intake of CO2 the plants okay so what value I want to perform on the t that is optic so what will I write here this is optic. Mu mu is equal 30. What is mu here? Okay, this is the population mean. So these are the sample means if considering this only of that I'm this these are the sample sample values and I required that I am that in case of t test the data set should be small less okay, we publish and upon that. So these are the sample values, right? So whenever I just select, click and run, or I will press Control and Enter, see the output. What you can see here, that one sample t test okay it is automatically giving that we are performing one sample t test because we have taken the sample we have taken the population mean also that means the one sample t test only two things are required that is the sample mean and the population mean okay so here we are performing one sample t test data is taken that is optic is the variable optic and the test. Okay, so whenever we perform t test, we found the value that means minus 2.3619. This is the t test value. And here you can see DF. DF means of freedom. Whenever I teaching hypothesis, at that time I told you what is degree of freedom. How find out that is n minus 1. What? This is the number precision. So after getting that is 0.0252 that is less than 0 that if the p calculation if we are getting the p value as less than 0 we have checked the null hypothesis is greater than 0.05, we favor null hypothesis. That means we accept the null hypothesis if p value is greater than 0.05. Okay, make a note of this. So everything, the execution that whether the alternate hypothesis will be accepted or whether the null hypothesis will be accepted depends upon the p value. So after getting the p value, for that we need the alpha value, we need the degree of freedom. Okay. So after getting the p value, we have to check whether it is less than 0.05 or more than 0.05. If the p value is less than 0.05, we reject null hypothesis. If p value is greater than 0.05, we accept null hypothesis. Right? So as you can see that p value is 0.02. That means it is less than 0.05. So we have to reject null hypothesis. Okay. So null hypothesis says what? We see the population mean 30 and this is the sample we want to take. So the null hypothesis always say that there is no difference. That means here in this statement, the null hypothesis say that there is no significant difference between the population mean and the sample mean. So we have taken the population mean as 30. So after getting the sample mean, after getting the mean of the values present in the sample object, so the null hypothesis will say that if mu is equal 30, the population mean is equal 30, uptake mean will also be 30. So there will be no difference. But we have to check that whether the sample mean and population mean are equal or not. Okay. So whenever through the execution, through the coding, we got that the p value is 0.02, that means less than 0.05. So as it is less than, so we have to reject the null hypothesis. So null hypothesis say that there is no difference. That means mu and the sample mean is same. That means if you had written mu as 30, sample mean also 30. So we have to reject the null hypothesis. That means we will say that sample mean which is not equal to the population mean. Okay. So let's see that what is the sample mean here. Sample mean is 27.31. We have taken the population mean as 30. That means these two means are not equal. That means here also we can get null hypothesis is rejected. Okay. So here alternate hypothesis will say that the mean is not equal to 30. That means the sample mean is not equal to 30 and the population mean is not equal to 30. So here alternate hypothesis will say that mean is not equal to 30. This is the alternate hypothesis will say. So as we are able, we are getting 4.86622 for the sample and for the population mean is 0.05. So we have to check that here the sample mean is not equal to population mean. So as we are able, we are getting 4.86622 for the sample and for the population. So see the coding, see the execution, and just confirm me that you are getting all the things what I have mentioned. Yes,
Hello?
Anas, want to ask anything?
Yes,
Yes.
I want the question. The question is come.
MU. This is good question. See that MU,
Mm,
that means the population mean that we are writing 30 because
mm,
in case of t test we have to consider the population, that the entire data set that should be equal or less than 30. We cannot take more observations in more data set or the more values in the data set that is greater than 30. That means whenever whatever the data sets we have to take, we have to make the mean of the entire data set that is equal to 30 or less than 30. So approx we have to consider 30 as we have to take. We cannot take more more than 50 for the t test. So whenever you check the data set for the t test, always remember that in case of j test it can be greater than 30, 40, 50, 100, 120, etc. But whenever we are considering the t test, always consider the population that should be greater than 30. That means if we are considering the population of 30, that means our population should be equal to 30, not less than 30. Don't be more than 30.
After observation that if the p-value is greater than is less than 0.05, we have to reject the null hypothesis.
No, no,
And
no,
if
no.
it's greater
See, p value,
p-value,
if p value, yes, p value, if it is less than 0.05, we have to reject the null in that case.
yes. Okay. So what if the p-value is equals to 0.05, is equivalent to 0.05?
See, one thing that whenever you will get something, whenever you are doing the operation, always you will get to two types. That means that should be less than 0.05, that should be greater than 0.05. That means when the maximum cases, in maximum cases, that it is happened, it is just seen the experiment that whenever we'll take the data set, that is you will get, suppose you are doing the analysis and you are getting the p value that is something that is less than 0.05. That means, so in that case we have to reject. Okay, and maximum we have that means two categories, that is less than 0.05 and greater than 0.05. Okay. So there is no case of equal to 0.05. Okay, so you will get the p value in that way, because if you have seen at that time the table that I was showing, the value is, that means not there is nothing written as 0.05. That is always less than 0.05 and greater than 0.05. If you have seen, so to get the p value, we need alpha, we need df, that means degree of freedom. For that we have to check if the p value that is that is fixed. Okay, that p value is fixed. That means if the alpha value, as you know, the alpha value is zero point 0.5, you can get 95% confidence, you can see that 90% confidence, you can see 80% confidence, you can see 85% confidence. More alpha you will find the degree of freedom as per the data set that you have given. So according to that you will get the p value that will always be less than 0.05 or greater than 0.0. That is, there is no column of equal to 0.05 there, if you have noticed at that time.
Okay, understood, ma. Thank you.
Okay, any question? You can also download the PDF that we download that from the internet. Okay, in the examination you won't remember all the p values, we cannot. Okay, so at that time it will be provided with the p values at that time by the institution, or even by something hypothesis. So we have the supplement that if you want to find out the p value, then you have to use the supplement that we will provide you in the link. Okay, any doubt? Okay, anything want to ask any students or you can also that can be in this way that if you are asking that if p value is 0.05, that means the null hypothesis, you can say that we know that there are two hypotheses. So if the p value is 0.05, if in some cases it is 0.05, the null hypothesis has a 5% chance of being true. Okay, the null hypothesis has 5% chance of being true. That means we can see that the non-significant p value means there is no difference between the group. That is the difference. Right. So here also you can conclude that if suppose as per your doubt that if we are getting the p value, let we are getting the p value as 0.05, we obviously get we two categories we generally consider, that is less than 0.05, greater than 0.05 for the p value. So if we are getting that p value is equal to 0.05, less than 0.05, okay, if in some cases we are getting less than 0.05, that we up to that we have to reject the null hypothesis. Okay, so if we are getting the p value is greater than 0.05, we have to accept, or we fail to reject the null hypothesis. That means the observed data should be that means it would be obtained only 5% of the time, that if the null hypothesis were true. Okay, you can also conclude in that way. Okay, Anas, am I clear to you?
Yes, my cleared.
So that means if it is judged as p value is less than 0.05, it is judged as significant one. And if the p value is greater than 0.05, it is judged as non-significant one. And if the p value is greater than 0.05, it is judged as significant one. Okay. And since the significance probability of taking the sample from the entire population is value set, you can say, by the researchers that have set the probability significant value, it should have to be data set have to be 0.05. So that's why we take that is less than 0.05 and greater than 0.05. We just put the data sets into two categories, that is less significant and significant. Okay. Any other things you want to ask? Okay. Are you clear about this p value? Any doubt from anyone? So that you see that if P value is greater or equal to alpha, that means it is not a statistically significant array. Okay, any doubt? Any other doubt?
It's clear.
Okay, so let me rewrite this. That means this is what? This is the significant array. Null hypothesis said that there is no difference. These are equal. Okay, so we always and our main hypothesis. If you see that the statement is if p value is less than 0.05, that means study is not significant. Okay, that means we have to accept the null hypothesis. And you see that if you remember one thing, you are asking that it was if p value is less than 0.05 or it is also in p value is less than 0.05, till then most of the cases, obviously, we will accept the null hypothesis. If it is 0.05, accept 0.05. But in rare case, if we get that is 0.05, it is less than 0.05 also, we will reject the null hypothesis. But whenever you see that our is most statement that when we analyze the p value that very rare cases it comes is equal to 0.005. Okay, so in that case we accept the null hypothesis. Am I clear? Then next see one more example. I will just show you. This is what? This is our that I told you, that is one sample t test. Okay, this is one sample t test. I want to perform here independent t test, that is one sample t test independent. Here the independent sample t test, because sample t test and dependent now concluded with the will now perform the independent sample t test. What is this? We have to perform, we have to find, okay, these two groups, two different samples are there. We have to find the mean of this first sample group. We have to find the mean of this sample group, and will check that we have to accept the null hypothesis or we have to reject the null hypothesis. So null hypothesis will say that there is both mean are same, although there is difference, either less than, greater than, or not equal. Then we have to just write this is called independent sample t test. You see that late I want to perform this, perform independent sample but right t test. I have to take the object and write the type. That means as I have taken this sample and I will just write the type. Note that in case of object, you have to get two types of tree. That is QBAC, the object, that is object that is tree. That means we have to make tree and perform two groups. One group can one group one, and we'll consider the null hypothesis and we'll accept the QBAC. This is the type. So the type cake and the Mississippi. So as it has two types, so we will get two different groups. So alpha hypothesis will be accepted, reject. So write here mu equal 0. That means the difference between population mean of these two samples, right? Then alternate. Alternate hypothesis we can write alt is equal two sided. See, alternate hypothesis has three values. That means it can be greater than, it can be less than, it can be 2.sided. Alternate hypothesis is 2.sided. Then we have that is equal less. We have mentioned here alt is equal 2.sided. Then confidence level is 0.95. That means alpha value is 5%. And we have to write this paired is equal false. Paired is equal false. Meaning of this that we are not performing the dependent sample t test. So paired is false means two groups are different. Okay. So paired is false means two groups are different. So two groups are different. So that means we have to accept the alternate hypothesis. So alternate hypothesis say that there is no difference between the two groups are different. So that mean of the Quebec is 33.54 and 20.8. That means the difference is 20%. So here you can see that we have taken two groups are different. Type has been taken different. It has two types. Two groups are different. And the value of t, okay, is 4.44 e power minus 9. So when we calculate the value, so this will be less than 0.05. Okay, you just find using the calculator 0.05. As the p value is less than 0.05, that means we have to reject the alternate hypothesis. So alternate hypothesis will say that there is difference between the difference null hypothesis say that there is no difference. Null hypothesis say that there is no difference. The difference of these two means are 33 and 20. Quebec and the Montreal, there is the difference. So that means we have null hypothesis. So we will, if we are rejecting the null hypothesis, we have to accept the alternate hypothesis. So alternate hypothesis say that there is difference between the Quebec and the Mississippi. So that is not equal to 0. We have written here mu is equal 0, so that is not equal to 0, right? So this is your independent sample t test. Okay. Okay. So up to this, any doubt? We'll just stop the session today, and tomorrow we'll continue with the other studies, other test. Okay. So up to this, any doubt? Or are you clear? Or after the session you will just run by your own using this coding that I told you, and just inform me that whether you just received the same output, or at any point you are facing any difficulty, you want to ask, you are confused at any point, you can ask me at any time. Okay. Okay. Okay, everyone present over here, are you all clear about today's coding
Yes, we
that
are.
I told so many things? Yes, Anas, do you want to say anything?
No, I said it's clear. We understood it, man.
Okay, okay. Thank you. What about the others? Are you all getting clear? Lesson is clear to everyone? I will also explain the same thing. I will give a brief recap about today, what I taught today, tomorrow also. Okay, so don't worry if anybody just missed today's class.
Mom, I joined late for the what you just did. I'm okay. I've gotten it.
Okay, okay, okay. No issue,
It's
no
only
issue.
the
I
thorough
told no.
aspect that
Yes,
I'll
yes.
do.
Okay, so tomorrow I will explain this again also. Okay. also for the students those who have missed today's class. I will just explain again tomorrow. So same thing. We'll give a brief recap. Okay. So am I clear to everyone till now?
Yes, ma'am.
Okay, okay. So thank you so much. Let's stop the session and we'll meet tomorrow. I'll just will okay. So everybody just enjoy the day.
Okay.
Okay. So thank you so
Okay.
much.
Okay. Okay. But is this normal time that we're having tomorrow's lecture or rescheduled time
Okay,
like
this
today?
is this timing is okay for
Yes,
you
this
all.
time
Every
it's more convenient because that afternoon
okay, okay,
as we are
okay, okay,
workers.
sure, sure. Okay, okay.
Yeah, this
Okay.
time is okay. This time is okay. The earlier this time is
Okay,
okay.
okay. Okay, 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 okay. In the morning. So if you are agree, yes.
Yes, it's
Okay,
more
okay,
convenient,
okay,
ma'am.
okay.
Yes.